Math 3, Unit 7, Section 3. Today we are talking about how to find the formula for a parabola given a focus and a directrix. Remember how I said we need to know the definition of a circle? Do you guys remember what the definition of a circle is?
No straight edges.
It doesn't have straight edges, that is correct. But specifically, if you go back into your notes, a circle is a set of all points in a plane that are equidistant from a given point in the plane called the center. Do you guys remember that?
Yes.
Okay. The other definition you need to know is a parabola. Okay? And a parabola is a set of all points equidistant from a given point and a given line. Okay? The point is the focus, and the line is called the directrix. A parabola is different from a circle in that in a circle it's just they're all equidistant from the center, where in a parabola it's equidistant from a point and a line. Okay. So we have a parabola. Do you guys know what a parabola looks like? The U shape. Good. Okay, so as we go through here, and you might want a highlighter, we have the focus is at 0, 2, and the directrix is at y equals 2. The focus is a point. We're going to go ahead and plot that on our graph. Okay, so at 0, negative 2, I'm going to make a point here, and I'm going to give it an F label to remind me that's the focus. The directrix is at y equals 2, so we go up to 2, and the directrix, it's a dotted line. Okay, and that is y equals 2. I'm just going to label it there. Could you find the middle between the focus and the directrix? Where would it be? 0, 0. This point here right in the middle, this is your vertex. Okay, and so our vertex here is at 0, 0. I'm just going to write that there. Your parabola always curves around the focus. So, and like away from that line. Okay? So we're going to go ahead and leave this the way it is for right now. And we're going to go ahead, and it says use the formal definition of a parabola to derive the equation in descriptive form. So, our equation, what they've told us, is that a parabola is a set of all points equidistant from a point and a line. Okay? So that means that from the point to the directrix, we're going to write this as PD, this distance right here from a point to the directrix is equal to the same distance from the point to the focus. Do you guys remember the distance formula? You learned it back in Math 2. We've talked about it this year. Distance formula. We're going to write this out. Distance formula. So you can find the distance between 2 points with this formula. So you need to have 2 points in order to use the distance formula. The distance formula is this. It's the square root x2 minus x1 squared plus, good job, y2 minus y1 squared. And we're going to be using this distance formula a lot during this unit. So, the point for all, when we're deriving the formula, the point that we're going to use is just xy. We're going to call the point xy. The directrix, do you see here how we have the directrix? Do you see how it says y equals 2? So for the point for the directrix, we're going to use 2 in the y spot, and since there's nothing in the x spot, we're just going to give that an x. On the other side where we need the 2 points, again, we're going to use the point is going to be xy. And then the focus, do you see how the focus is a point? We're just going to keep that as 0, negative 2. And then all we're going to do is plug this point, these 2 points, into our distance formula, these 2 points into the distance formula, and then we'll simplify. Okay? Are you ready for this? Okay. So for the distance formula, it's the square root, and all we're doing is subtracting the x's. So in this case, for these points, it's just going to be x minus x squared. So this is like your x1 and your x2, or vice versa. It doesn't matter which one is which. Okay, and then you do plus, and then we subtract the y's. And I'm going to write that as y minus 2 squared. It's important to always have like the y come first. Equals. On this side, same thing. Okay, we're going to subtract the x's, and you would want the x to come first as well. So I'm going to write this as x minus 0 squared. Plus, and then for the y's, how would I write that? Y minus negative 2 squared. Good. I'm going to make this a little bigger for you guys. Okay, so now we're going to simplify. What is x minus x? 0. Okay, and so just so it's in our notes, I'm going to write this as 0 squared so you know what happened with that first parenthesis. And then we would keep y minus 2 squared equals, over here when you have x minus 0, that would make what? X squared plus, and then those two negatives would simplify and make y plus 2 squared. Any questions so far? All right, the next thing, do you see how we have a square root on both sides? And this goes back to unit 6. How can I eliminate a square root? Good, we have to square both sides. So when I square both sides of the equation, what happens to each of those square roots? They eliminate. The square roots and the squares eliminate. And I just did that to the entire equation. So now I'm not going to write 0 squared anymore. Are we okay with that? So I have y minus 2 squared equals x squared plus y plus 2 squared. Now, do you notice how these are y's and these are y's? We want to combine like terms. So we need to multiply these out. How would I multiply out y minus 2 squared? Punnett squared. So we're going to kind of go to the side right here, and I'm going to make my Punnett square. And we have y and negative 2 and y and negative 2. And I'm hoping at some point you guys might be able to do some of this multiplication in your head, but if you can't, always use your Punnett square. When you multiply this, y times y makes y squared. Y times negative 2, negative 2y. Negative 2 times y is negative 2y, and negative 2 times negative 2 is positive 4. Our diagonals right here, these are like terms. And so when I write this out, I have what? Well done. Y squared minus 4y plus 4 equals, I still have this x squared there. And then I'm going to multiply this out. What is different between this one right now and this one? This one has a negative, this one has a positive. So because I don't feel like totally writing all out again, I'm going to make this a positive and this a positive. And if I go back to remultiply, this changes to a positive. This one changes to a positive, and then that is still positive 4. And when I write that out, what do I get? Good. Do we have any questions so far? Anytime you have two terms that are exactly the same on both sides of the equation, what will happen to them? They cancel out. Do we see anything here that will cancel out? Okay, y squareds are going to cancel out because they are exactly the same. Anything else? The positive 4s will cancel out. Will these cancel out? No, because they're opposites. Now, when you have a quadratic or a parabola, we always just want the y by itself. Okay, so the y goes on the left side of the equation by itself, and then everything else is on the right side. Do you guys remember this? Okay, so that means we are going to end up moving the 4y to the other side. How do I do that? Good, subtract 4y. We get negative 8y equals x squared. And what's the last thing I would do in order to get the y by itself? Divide by negative 8 to both sides. And so we end up getting y equals negative 1/8 x squared. And you would pull that fraction out in front. That's like your a value. And we just derived the equation of a parabola using the focus and the directrix. So one other thing I want to show you over here, and we're going to learn about this here too in a little bit, is that the definition is that it's the set of all points equidistant from a given point and a given line. So do you see how here's the point, here's the line, right? How far is this distance? 4. Can you think of any other points on here that would also be exactly 4 away from the point, a point and a line? This point right here. Do you guys see how this is 4 away from a point and it's also 4 away from this line? Which means you could go the opposite way. That's also 4 away from here and 4 away from here. And this is your vertex, and we know that this would curve. And so this is just a more accurate way of drawing a parabola. Okay, so we're going to do one more. Are you guys ready? So if we start with just drawing the parabola, we have our focus at 0, 5 and our directrix at -5. And so if we are to put this on the graph, let's go ahead and plot this. So 0 up 5, we're going to give that a label of F for our focus. And then we go down to y equals -5 right here for our directrix. Your vertex is always right in the middle of those two. And so where would our vertex be? Good, 0, 0 is our vertex. Can you guys figure out where any other points would be on this graph? So if it was 5 away here, then it would be 5 from here, but 10 from the line. If it's 5 away from the vertex. So when you're curving this, the parabola is going to curve around the focus. So it curves like from the vertex around the focus. So remember, if you look back up here, how this distance, it was 2 away here, 2 away here, but in order, we went how far from the focus in each direction? 4. Very good. It'd have to be 10. So you'd go 10 would be a point over here and -10, 5 over here. Is this, so this is 10 from the line and 10 from the point. 10 from the point, 10 from the line. So there's our graph, but we have to derive the formula of this graph using our point and our focus and our point and our directrix. Are we ready? No? Okay. Hopefully you will be by the time we get to it. All right. So we are going to always write out point to directrix, so PD equals point to the focus, PF. The point that we will always use is XY, and then we get the information for the directrix. And in this case, the directrix is telling us what? Y equals -5. So we're putting negative 5 in the y spot, and anytime there isn't anything in the x spot, we just write an x. On the other side, our point that we always use will be what? xy, and then the value for the focus is what? Well done. Next, in order to find that distance between our point and our directrix and the point and the focus, we have to use the distance formula. So our distance formula is the square root, and we subtract the x's, so that will be x minus x squared plus what? Y minus negative 5 squared. So pay attention if there's negatives. Equals. On the other side, what will I write? Good. X minus 0 squared plus y minus 5 squared. Well done. Then we simplify. X minus x is 0. So I have 0 squared plus, and two negatives make a positive, and I have y plus 5 squared equals. X minus 0 is x squared plus, and then we have y minus 5 squared. Who thinks they know what we should do next? Why am I going to square both sides? Eliminate the square root. Well done. Square both sides, and so when I square a square root, that eliminates. Oops. And I have y plus 5 squared equals x squared plus y minus 5 squared. We can use a Punnett square if we need to multiply this out, but we know from completing the square even that when I write this out, I'm going to have y squared because of y times y, and then we add the 5s. 5 plus 5 would make 10y, and then 5 times 5 would make 25. Is that okay that I do that without the Punnett square? Okay, and then we have x squared plus, on this one we'd have y times y, which is y squared. My middle term would be negative 5 plus negative 5, which makes negative 10y, and my last term is negative 5 times negative 5, which is positive 25. Are there any like terms on both sides that I can eliminate? Very good. Y squareds and the 25s. I am left with 10y equals x squared minus 10y. We always want the y to end up being by itself, so what will I do next? Well done. Add 10y. That eliminates. What's 10y plus 10y? 20y equals x squared, and then the last thing I do is divide by 20, and I end up with perfect. Y equals 1/20 x squared. And that is the equation for this graph. What do you guys notice about like the widths? You know how like this one's pretty wide? This one's not as wide? The smaller the number, the wider it gets. Yeah. Okay. Are we good so far? Also, did you notice how this one's pointing down and there's a negative here? And this one's pointing up and there's a positive. Okay. Is that awesome? Okay, I'm sorry for not letting you say that. Okay, moving on. Okay, this next part is our general formula exploration. Okay, so we're just going to figure stuff out about the formulas for parabolas. The first thing they say here is to let C equal the distance from the vertex to the focus. First of all, the vertex is not marked on here. Where would the vertex be? Very good, because the vertex will always be directly in the middle of the focus and the directrix. That is my vertex right there. So it says let C equal the distance from the vertex to the focus. So what they're saying is from here to here, we are just going to call that C. That is the distance. Now that we've done that, it says label point F on the diagram. So if this distance is C, what would the ordered pair be for F? It does go X and Y, but what would the X value be? How far did we go on the X axis? 0. And then you went up C. So that ordered pair right now would be 0, C. Next, number 2, it says on the y-axis, find an expression in terms of C for the total distance from F straight down to the directrix. So here is F, right? And then down to the directrix. How far would that distance be?
C squared.
Close. 2C. Because this distance would also be what? C. And C plus C is 2C. Okay. Then it says, how does this expression relate to the distance from point P to point D? So from P to D, what is that distance going to be? Also 2C. And I'm going to put it's the same. What does the definition of a parabola tell you about the distance from PF and PD? If you go back to the page before, PF and PD are what? They are equal. Does that make sense? So from PF, right here, to PD, they are equal. So therefore, what is this distance? 2C, very good, because you guys told me that this distance was 2C, which means that this distance also has to be 2C. So now let's label point P in terms of C. What you have to think about is if this distance right here is 2C, what's this distance right here?
2C.
And what's this distance right here?
2C.
So on the X, how far am I going over? 2C. And then how far did I go up? Just C. For point D, in terms of C, what would this be? 2C and negative C. Because we're going down, it would be negative C. Okay, now it says add another point Q in the second quadrant, right here. That would also have to be on our parabola. So you know how this is our vertex and it would hit this point right here? They want Q over here. So we're going to make a point Q right here. And we know that it would end up curving like this, right? What would this Q be labeled as based on everything that we know? Negative 2C up C. Good, because this would also need to be a 2C distance. Okay. Next question. What is the total distance from Q to P? So from Q all the way to P, what is that total distance? 4C. Well done. This is going to come into our formula when we finish this up here in a minute. Okay, so we're going to turn the page. You ready? Yeah. Okay. Here is all of our information. Okay? Now, we have our PD equals PF. Our point is always going to be XY. In this case, though, our directrix is X comma negative C. Our point, again, is XY, and our focus is at 0C, just like we had on our previous page. Okay? Now we are going to use our distance formula in order to find the actual definition of a parabola. Okay, so what is going to go in this first parenthesis? Good. And the next one? Y minus negative c. Make it a little bigger for you guys. And then the next parenthesis is going to be x minus 0 and y minus c. Good, square. Okay, so now we simplify. X minus x will make 0. I'm just going to write it here for now. And then two negatives make a positive, and we'll have y plus c squared equals, over here we have the square root. X minus 0 would be x squared, and I don't know why I did the parentheses, you don't have to have them, plus, and then we have y minus c squared. What's my next step? Why am I squaring both sides? Very good. Square both sides in order to eliminate the square roots. And so when I do that, I end up with y. Good. Perfect. Now we have two sets of y's. Do you guys agree? And we need to combine like terms and eliminate things. This to me looks a little confusing, so I think that we should use the Punnett Square to multiply it out. Is that okay? Yeah. All right, so to the left here, I'm going to go ahead and make a Punnett Square, and we will label that as y plus c and y minus c. This first one, when I'm multiplying, sorry, this is a c. It doesn't look like it though, huh? Y, oh, they're both pluses. I apologize. There we go. Better? Good catch. Okay, y times y is? Good. Y times c is? Good. Y, or c times y is still? cy, and then c times c would be? Okay. These are both like terms. If they're both 1 cy's, my middle term will end up being a 2 cy. So we're going to write this out. We have y squared plus 2cy plus c squared equals x squared plus, now for this one, all I need to do is make these what? So if I make that a minus c and a minus c, what happens in my Punnett square? Good, both of these end up becoming negatives. So when I write it out, what will it be over here? Good, y squared minus 2cy plus c squared. What is like that will cancel out? Okay, c squareds, y squareds, and let's write out what we have left. 2cy equals x squared minus 2cy. What should I do now? Good. Add 2cy to both sides. 2 plus 2 is 4cy equals x squared. And in order to get y completely by itself, what will I do? And now y is by itself, and I would write this as y equals, we always pull out everything in front of the x squared. So that would be 1 over 4c and then x squared. So our equation for a parabola is y equals 1 over 4c x squared. This 4c should look familiar. 4c is always that total distance across from your focus. Okay? We are going to turn the page. I know we're going a little longer than normal, but your actual release time is supposed to be 48. So bear with me. We're going to just go a little bit longer today. I will make up for it another day. I promise. Okay, here we go. So now this is where it actually becomes kind of easy. Okay? Are you guys ready? Yes. Here we have this parabola equation. We know that, first of all, do you guys know where the vertex is on this parabola? 0, 0. because there is nothing in parentheses with the x squared and there's nothing adding at the end. So we're going to go plot a point for our vertex. Now, we can make all the other points on this graph knowing our formal definition of a parabola, which is y equals 1 over 4c x squared. We want to find the c distance. Remember how the c distance went from the vertex and made the focus and also made the directrix? Do you guys remember that? Yes. So how could I figure out how much c is? This is what you do. You set up an equation, and we're going to write 4c equals, and it's always the reciprocal of this value. So what's the reciprocal of 1/8? 8. 4c equals 8. And then we divide by 4, and we find that c equals 2. Okay? So from the vertex, because this is going to curve going up, my focus is 2 up, and we're going to label that as your F for your focus. And the directrix is 2 down from the vertex, and we label that. So our focus, ordered pair, is at what? 0, 2. And your directrix is at y equals -2. Your focal chord endpoints, the total distance is 4c, correct? Okay? So that means if you're going halfway, the halfway, like to this side, would be how much? Based on everything that we did. It's 2c in each direction. Do we agree?
Yeah.
Yeah. And so what I would do is I'm just going to go 2c equals 2 times c is 2. So therefore, my distance is going to be 4. So from the focus, we go 4 in each direction. We just count 4. 1, 2, 3, 4. And this way. 1, 2, 3, 4. And then we can completely draw our parabola. And the focal chord endpoints are these ordered pairs, which are at, good, 4, 2 and -4, 2. And it doesn't matter which way you write those. We're going to just do one last one. Okay? This one, y is not by itself. What do I do to get y by itself? Divide by -6. Now that I've done that, I have y equals -1/6 x squared. What is my vertex? 0, 0. Nothing is with the x squared, so the x value is 0. Nothing is adding at the end. The y value is 0 for my vertex. In order to find my c distance, we always take 4c equals the reciprocal of this value. So in this case, that would be what? Good. Then we solve for c. We divide by 4 to both sides, and we find that c equals, I'm going to make it a decimal so it's easy to graph, and that would be what? -1.5. Okay, so this is my vertex. For my focus, I'm going to go down 1.5, and that is my focus. For my directrix, we go the opposite direction, 1.5, and so we would go up for our directrix at 1.5. What is the ordered pair for my focus? 0, -1.5. The directrix is at y equals 1.5. How do I find the focal chord endpoints? Those are always how far? They are always 2c. So in this case, we would go 2 times -1.5, which equals what? -3. And really, it doesn't matter if it's negative or positive. The reason why it's negative is because the parabola is going down. But all that means is I'm going to go 3 in each direction from the focus. And then we can draw our curve. And then those ordered pairs are at -3, -1.5, and +3, -1.5. Okay, I'm going to go ahead and do the last example. If you need to leave, you can. Okay, but I'm just because of the video, I'm going to go ahead and finish. So the last one, in order to get y by itself, again, I divide by 12. we end up, if you guys can just be quiet, y equals 1/12 x squared. My vertex would be at, good, 0, 0. In order to find how far I go for my focus and directrix, we always use the formula. 4c equals the reciprocal of 1/12, which is 12. We get c equals 3. So I'm going up 3 for my focus, down 3 for my directrix. The ordered pair for my focus is at 0, 3. My directrix is at, and in order to find the distance for my focal chord endpoints, it's always the distance of 2c, and so 2 times 3 equals 6. So I'm going 6 in each direction from the focus. I'm able to make my curve, oops, hopefully you can do that better, make my curve. And the focal chord endpoints are at 6, 3 and -6, 3.